In exercise 13.5 number 3, you're asked to sketch the graph of the function y is equal to 2x squared minus x cubed. You're also asked to show the turning points, find the turning points and the nature of them. Now, it probably pays when you're doing these early on to have a look at what the function is going to look like. So you've got a bit of a check here. You can see the general shape, the turning points. I've clearly got one at the origin, and that's going to be a minimum. You can see an x-intercept at 2, and we'll just check to see what the maximum is. So the maximum there occurs at 4/3 and 1.185, and that's going to be a maximum. So it would pay to have that by your side as you progress through with this particular problem. Now, first thing we're going to do, the y-intercept, and clearly that's the origin. The x-intercepts, when y is equal to 0, so solving that, I'll just put it in the negative x cubed format. So when I do that, I have negative x squared into x minus 2 is equal to 0. So therefore, zeros at the origin, which will be a double, which approaches the minimum as we saw, and when x is equal to 2. Now the next job I've got to do, I've got to locate the turning points. And they, of course, occur when the derivative is equal to 0. We know one's already at the origin. If I take out negative 3, that will give me x minus 4/3 is equal to 0. So when x is equal to 0 and x is equal to 4/3. So when I plug those values back in, I get the origin. And when I plug the 4/3 in, I get 32/27, all by the magic of the calculator. And the point, 4/3, 32/27. So sketching up the graph, you can see those following points. Now, when it comes to determining the nature of the turning points or justifying my turning points, I can put in a few values. I already know when the origin's 0 that the value is 0. I better make that 1. 4/3 and 2 here. That in turn is going to be 0 as well. So when I plug in a few particular figures, when I'm looking at the derivative, that's dy over dx is going to be negative 3 by 1 plus, or take 4, which is definitely negative. So my sign goes from negative to 0 there. And I reckon if I plug that through very quickly, negative 3, that's going to be 1. So already I have around x equal to 0, the sign of the derivative, goes from negative to 0 to positive, therefore a minimum, and around x is equal to 4 over 3. You can see the sign there, goes from positive to 0. I better just quickly put that in there. dy over dx is going to be negative 3 by 4 plus 4 by 2, negative 4. And that corresponds to the maximum. Using my ruler to demonstrate, you can see the slope, negative, 0, and then positive, around x is equal to 0, and from positive to 0 to negative, around x is equal to 4 over 3.